认真，我也在看到这个。
做出来3个呢？啊？
好像是你的 not，很像你的 not。看下
你说反着做啊？
有过疑问呢？因为我们只是证明啊，series 它有包的，有包的，而且 monotonic，也算是 converge。但是为什么 series
因为你是看着这个 sequence 这是一个 sequence of series，就你的 sequence 的 term 全部是 series 的。就是你 sequence 的每个 term 是 series 来的。比如说第一个 term 是 A，第二个 term 是 A，整个是一个 term，
我就把它当成一个号码，一个号码就可以哦。
因为 finite 的话，你肯定能够讲出来。
我年那时候就学到一点东西啊。命题啊，这样子啊。
之前是 non-decreasing，
那决定
应该是可以。但是我是说，你还有一个 proof 是可以直接从那个有的东西变成这个，只要往那个 constant，
那个公式
对，往那个 constant，因为你小于零嘛，你小于零的话，你的这些 a n b n 可以写成减 c n 或者减 d n，负的一个东负不是整个 equation 会变掉，整个 equation，然后你整个乘了负了过后就变回我们那个 k 的。然后就用我们的 case 来 deduce 那个 converge，然后你再重复回去你的 series，那 series 它是 converge，所以它有可能。
你讲的那个点，这样不就是它又是另外一个 series 啊？因为一个 sequence 啊不是？
这样讲。
你讲点，你要让它
就把它写成，因为这些全部都是负那个地方，那哪个地方嘛，不是可以写成减一个 positive 号码
yes，
啊？
但是
就是说我 replace 这个 an 成减 cn，就是说就是 cn 是正号码，全部成一个减啊，就是我把它的减抽出来。
yes，
然后我这边减 cn，这边也可以减 dn。
哦，
那我整个减拉出来的话，就变回我有个 case 了，我有个 case 已经 convert 了。那 convert 的话，我再乘一个减回去，是不是它们的 series？
yes，
啊，yeah，可以啊，这2个 proof 都可以用，可以跟他写下来，如果你要。 写不同的 proof，
哦，
就写在你的 project 里面。What's your question on the assignment? Okay. Okay. Can do it. Cannot. Okay. If you can get help from your friend, you also can get help from me. Okay. Yeah. But please write down who you collaborate with. Okay. I think we have to start. Not waste time. Okay. So last time we talked about this, right? Infinite series. This divergent, this diverge. How to show 1 plus 2 plus 3 plus so on diverge. Sum of natural number. This for divergence, okay? Limit of an go to infinity. Okay, so the series diverges. Okay. But I said that this is also equal to minus half 12, minus 1/12. Okay, how is it minus 1/12? Okay, we will use a technique called the Ramanujan summation. Okay, you play around with these three series A, B, and C. So A is a 1 plus 1, 1 minus 1 plus 1. So it's an alternating sum of 1. Second is the alternating sum of natural number. Okay, C is the series we are interested in. Okay, and then we play around with this number, this series. Okay. And then you get minus half. Okay, so if you are interested, this is a very good project topic for your project 1. Because why? Because this will have a real life application for the next part, project 2. So you can have a continuity in your project. Okay, so as like what I said last time, so the real life application of this summation is in quantum physics. Okay, quantum physics. By the way, 2 days ago, Nobel Prize in Physics got announced and is given to quantum physics. Okay, for this year. Yeah, kind of the quite active area, research area nowadays. Okay, so if you are interested, please do some research on it and then talk to me. Okay. How many of you watch anime? Anyone of you? No. Little bit. No one. No one. Really? I find which year are you guys in? Like year of birth. 4, huh? I also have some friends from like after 00, like maybe 03, 04. They don't watch anime again. Is it because of TikTok? Or what? Why you guys watch? When you are young, childhood. Huh? Doraemon. Oh, still got Doraemon, okay. After that, TikTok. Huh? What you guys watch? Okay. Yeah, Ultraman. Okay, those are classic ones still goes. Okay. Okay, interesting. Because otherwise, if you watch anime, maybe there's something related to series that I can show you if you are interested. Yeah, from anime. Seriously, no one interested in anime. Is it too boring? Is it too boring? Okay. So yeah. So these series, I think we won't do it now. Okay, please go back and do this question. I'll post the solution. When you do this, right, don't sit there and then think about it. Okay, try read all the tests and then try use instinct to answer them. Okay, because why? Because in the exam you'll be given few of this kind of series, and then I'll ask you to find test to test for convergence. Okay. If you spend too long time thinking about it, you might lose time in the exam. Okay. Okay now. So use your instinct to answer first. So meaning I want you to train your instinct. Okay, I want to train your intuition. Okay. So how to train your intuition? You just think whatever you think. Okay, you think that this is correct, then do it. Okay. If it's wrong, never mind, you change. Okay, but don't spend a long time and then figure out what happened in one question. Okay. So wrong change. Okay. I mean, train your instinct, train your intuition, so that next time when you see this question, you will have better idea what test to use. Okay, not just testing everything. You get what I mean or not? OK， 做这些题目的时候，不是你不要花太长时间在看一题，就是一个方法，是一个方法，不管它对还是错，你不知道对还是错。OK， 做完它 ，and then check 答案，答案错不用紧改。OK， 我要你训练你的直觉。OK， 训练你的直觉。OK，yeah，train your instinct。OK，train your intuition， 训练你的直觉。我不是要你懂到完，但是我要你训练你的直觉先。OK，train your instinct。错不用紧，自己做嘛，不用紧嘛，错不用紧。OK，so if you have any problem with this question, you can message me, bring it out in the Moodle, and then we can discuss again. If we have time, maybe we'll come back. Okay, I think we're quite a little bit behind schedule. Okay, so let's start with power series. So don't confuse power series with P series. Okay, power series is not P series. P series is not power series. So there's a power in this series. So where's the power? Okay, where is the power? So a power series in X. Okay, typically is in X. About X equals 0. Okay, is a series of the form of coefficient, a bunch of coefficient in front of the monomial Sn. Okay, monomial Sn. So how should we read these? Summing from 0 to infinity. So a little bit careful here. Series here, power series typically we start with 0. Okay, not like before. Why? Because when you put 0 into Sn, what do you get? 1. Okay, so you drop out a constant. So you start with a constant and then degree 1 monomial, degree 2 monomial with coefficient, and then so on. Okay, so can you see the power now? Can you see the power? Yeah, power of X. Okay, so the first term is the constant, and then second term is the linear term, and then third term is the quadratic term, and then so on. Okay, so why we learn the series? Okay, so why we learn sequence, why we learn series actually is for the use of this power series. Later we will meet Taylor series also. Okay, so for example, so for what X? Okay, for what X does the power series converge of Xn converge? So when does this converge? So I pick my constant to be 1 in this case here. When does this converge? What series is this? Geometry series, good. So So geometry series, the ratio is what? What's the ratio in this case? X. Okay, good. So first term is 1. Okay, so when does the geometry series converge? When the ratio is less than 1. Okay, so not just the ratio, is the absolute value of the ratio is less than 1. So it converges as geometric series. Okay, so what's the sum here? Okay, so the sum is the formula a minus 1 minus r, which is 1 minus 1 over 1 minus x. Okay, so there's some significance here. Okay, 非常重要 significance. So what is going on here? So we have infinite sum on the left hand side. Okay, but it equals to some closed form of function on the right hand side. Okay, but this is only true when when the absolute value of x is less than 1. So this equality is not always true. Okay, it's always true when x less than 1. Okay, in particular, when is it not true? When is it not true? Sorry, when is it not true? When s equals to 1. Okay, when s equal to 1, what happened? Sum of 1. Okay, yeah, sum of 1 diverge. So yeah, okay. So be careful when you write down these equation of a series equal to some closed form. Okay, there's always a condition on x. Okay, so be careful when you write it down. Okay, next. Next, what do we have? So let's look at this sum here. So this sum is Sn over n to the power n. Okay. So what's this power series here? So you have 1 on the first term, and then half times x over 2 plus 1/3 times x squared over 2 squared, and then 1/4 times x to the cube over 2 cube, and then so on. Okay. So when does this converge? How to check whether when does this converge? What kind of test you can use? Huh? What kind of test you can use here? So so the first thing I like to use is the ratio test. Okay, everything, most of the thing can be solved by ratio test sometimes. Okay, so let's check using ratio test. So ratio test tells us what? When does this converge? When the limit of absolute value of who and who. 2an plus 1 over an is equal to some finite number. Okay, some finite number. Okay. Do we need more condition? We need more condition. Is this a ratio test? That's not just in the middle, right? It's less than 1. So what's this condition when it is finite? What is this for? So this is the limit comparison test. So what's the limit comparison test again? Suppose an is greater or equal to 0, and then bn is strictly greater than 0, and then limit need absolute value or not equals to L. Okay. If L is finite, then so if L is finite, so there's one case is L is finite, then both of them converge or diverge together. Converge or diverge together. And then the other case is if L is 0 and Bn converges, then An converge. Okay. Yeah. So this is the condition for limit comparison test, not the ratio test. So ratio test is what? So let's recall what's the ratio test. I also forgot. Go together. So what's the ratio test? Okay. Any condition on An or not? No. Non-zero. You sure? If it's non-zero, why should we put absolute value there? Oh, non-zero. I thought you said non-positive. Okay, so let An be a series of non-zero term. Okay, very good. Why is it non-zero term? Why should we have non-zero term inside our series or ratio test to all? Because we're gonna divide our terms later. An plus 1 over An. But if your term has 0 term, right? What can you do? You will just discard it. Right? So if you discard the 0 from your series, let's say your series converge. Okay? Your series got 0 term inside. When you get rid of all the 0 terms, do you still get the same sum or not? Same, right? Right now. Because 0 doesn't contribute to the sum. You get it? 所以如果你有0在你的 series 里面，对不对？你的 series converge 图一个号码，那你把0去掉的话，你的 series 是不是还是那个号码？对不对 ？Okay, so we can discard all the zeros from our series and then build a new series which has the same sum if it converge. Yeah, if it converge. Okay. Okay. So there are how many cases in ratio test? 3 cases. Okay, 3 cases. So one case is the limit is less than 1. The other case is the limit is greater than 1. Okay. And then, so you have less than 1, greater than 1. The last case is equal to 1. Okay. So the last case is equal to 1. So what do we have? So in first case, we have the series converges. Doesn't only converges, but converges absolutely. So what does it mean by converge absolutely? absolute. No, not to zero. Not to zero. Okay, absolute means you take the absolute value of your AN. Okay, make everything positive. Add again. Converge. Okay. Original series also converge. Okay, both of them converge. So it converges absolutely. Okay, so you just remember one example, alternating harmonic series. Okay, alternating harmonic series converges conditionally. Why? Because after you take the absolute value, it becomes a harmonic series. So harmonic series diverge. Okay. So just remember this example. Then you will remember what is convergence. Absolutely converges conditionally. Okay. So L greater than 1, we should have. Also, there's a case L equals to infinity. Okay. So the series diverge. Okay. When L equals to 1, you cannot say anything. Okay. You cannot say anything. So the test is inconclusive. Inconclusive means what you have to do. Huh? Yeah, try another method. Okay. Don't stay with ratio test anymore. Okay, try another method. Okay, so it's less than 1 actually. So let's use this to compute. So let's compute limit n to infinity of an plus 1. N plus 1 term is x to the n plus 1 over n plus 2, 2 to the n plus 1. I hope you have question with you so that I didn't copy the question forward here. Otherwise, you need to believe me in my calculation here. Okay, so this is less than 1. So I want to make sure this is less than 1 for the series to converge. Okay, so if we cancel everything, what do we have? We left with? So we left with n plus 1 over n plus 2 times x over 2, less than 1. Okay. Okay. Okay, so how to compute this limit? Can we bring the limit in? No. Can we solve this absolute value or not? N plus 1 is positive or negative? Positive. N plus 2 is also positive. Okay, so we can bring n plus 1 and n plus 2 up. Similarly, we can bring 1 over 2 up. Okay, but x, we're not sure. Okay, so this x, I haven't really tell you where the x lies. Yeah, so where does this x lies? So this x could take values in a real number. Okay, so this x is a variable or a placeholder. Okay, it's a variable here. Does anyone confused why we got an x suddenly? So previously we only have numbers, right? Integer. Again, now we got this extra x. Okay, this x live in real. Okay. So notice that in this power series, right? We can change Cn. We also can change x. Okay. So changing these two will give you different series. Okay. Changing these two number will give you different series. Okay. But why is it gone again? But x, how does x change? X change in power. Okay, multiple. But Cn is any formula you can put in. Okay, but x change as a power. Okay. I think this should remind you a bit on the linear algebra. Okay, what do I mean by linear algebra here? So 1x, x squared, x cubed, x4 are linearly independent. Okay, are linearly independent. So they form a basis. Okay, they span the polynomial function in X. Okay. Yeah. Okay. So we reduced until here already. So this thing has to less than 1. So can we take limit n to infinity on this whole thing here? How to take limit? Yeah. Okay. Has anything to do with n or not? No. Okay. So this limit doesn't affect this x. Okay. So you can see x as some constant. Okay. For example. So really, you're taking limit on the fraction here. Okay. How to take limit on this fraction? You divide by n. Okay. Divide top and bottom by n. Okay. So I divide top and bottom by n. So all together, what do I get? I just get half times modulus of x less than 1. Okay, so you can see that this gives a condition on absolute value of x. Okay, so it converges only when x is in between -2 and 2. Okay, -2 and 2. Okay, so what happened at 2 and -2? Don't know. Okay, if we check when x equals to 2 and -2, this means the limit is what? Is what? The limit of an is what? If there's an equal sign here, if there's an equal sign here, if there is an equal sign here, if there's an equal sign here, meaning when x equals to -2 or 2, the limit of an plus 1 over an is equals to 1. Okay. Equals to 1 means what? The test is inconclusive. Inconclusive, what does it mean? Means it diverges or converges? We don't know. Okay, maybe it converge, maybe it diverge. Okay, so we need to check. We need to check at the endpoint. But away from 1, we surely know it diverge. Okay, but at endpoint still don't know yet. Okay, we need to check. So we need to check on this endpoint. Okay, so let's check on both of them. So one of them is x equals to -2. Okay, so let's put in the -2 into our function. Okay, so like what I said just now, when you fix x, it becomes another series. Okay, so in particular, this series here is the usual series with one variable, which is n. Okay, so what's this series here? So 2 to the power n and 2 to the power n cancel, where you just left with alternating sum of n plus 1. Okay, so does this converge or diverge? Converge or diverge? If you cannot see this series, right, as I suggest you just write down the term. Write down the term. When n equals 0, what is it? N equals to 2, 0, 1, 2, 3, 4, 5. And then what is it? What is it? Okay, write it down. Okay, what is it? So n equals 0 is what? 1. N equals to 2. Sorry. 1, 0, 0 from until 1. Okay, why is 1? N equals to 1. Minus half 2 or 3. And then minus 1 over. Oh, what is this? Alternating series. Okay, alternating harmonic series. So this series converges. Okay, as it is a alternating harmonic series. Okay. Why is it a bit different from what we had last time? Because we start with 0. Okay, so n got shifted. Okay. Similarly, you can just write like this. So we can shift our index. Okay, and then we replace our n by n plus 1. N minus 1 or n plus 1. N minus 1. Okay. So we can replace, we can rewrite this series. So rewriting series is an important skill in this course as well. Okay. So sometimes we rewrite a series, you need to realize that they are the same. Okay. 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 So how about the other endpoint? So one endpoint converges. How about the other endpoint? You try and guess. Quickly do the computation. Huh? So what? Yeah. What is it? Oh, yeah, I'll do it. Sorry. Harmonic series. Good. Okay, so this is a harmonic series. Okay, so it diverges. So at one endpoint it converges, at the other endpoint it diverges. Okay. Okay, so good. So that means that the power series converge. Okay. If we take our x in between -2 and 2, okay, and then including -2 doesn't include 2. Okay. Okay, how about I let you try 2 example. Okay, I let you try 2 example, have a hands-on experience. So let you try 2 example here. So first example is check the following xn over n factorial. And the other one is n factorial times xn. Okay, so I just swap the n factorial position and try and check when does this two converge. Okay, so remember our x live in R. Okay, our f live in R. Give you 5 minutes. Series. Yes, so one of them divide by n factorial, one of them is multiplied by n factorial. Do you want first guess first? Can you first guess which one converge? Which one converge better? Okay, later we'll see what does it mean by better. One of them, the coefficient getting bigger and bigger. One of them is getting smaller. And then later we'll see what does it have to do with x. In terms of case method, Kwani, are you Malaysian or Chinese? Chinese. So you why are you like in this batch? I thought the Chinese usually on the September batch. You transfer? Transfer from where? EGE. Okay. Sorry? Okay. 语言 卓金、金生、陈江、Ivan、思莹、Larry、罗浩、钟毅、小平、曾康、宜兴、罗山、郭汉威、水妮、燕如、若兰、汉伟。Okay, thank you everyone. You can chat answer with your friend. See, you guys agree or not? Try to answer with your friend. See if you agree. Can see? Wait, you done? What did you find? Very question. Okay, let's check. So you see, from these two, right? You see, the coefficient on the first one is getting smaller, 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 and smaller. But for the second one, the coefficient is getting bigger, 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 bigger. Okay. So what kind of x you multiply on both are they will converge? Okay, you should think like this first. Okay, you should think like this. And then we check. And then we use ratio test. This is max. So max is like this. We have a question. Okay. And then we devise a way to check. Okay, what's the way we devise? In this case, ratio test. Okay, we use ratio test. So let's check. Ratio test. They have to converge when the coefficient, the ratio of the coefficient is less than 1. So for the first one, we need to make sure xn plus 1 over n plus 1 factorial over xn over n factorial less than 1. Okay, so this less than 1. So you can see that most of the things get cancelled out. So what do you left with? You just left with 1 over n plus 1. Okay, everyone okay? This multiplied by absolute value of n. So if you take limit of 1 over n plus 1, what do you get? 0. Okay, 0 times anything is just 0. 0 is always less than 1. So it's always true. Okay? Meaning whatever you put in, okay, the limit less than 1 is always true. Okay, so in this case, we will say that the series converges everywhere. Okay, everywhere. Okay, so this kind of makes sense. Makes sense. What do I mean? Match our intuition. Okay, because this coefficient decrease fast enough. Okay, for the series to converge. Okay? At anywhere. In fact, at anywhere. Wow, not just at somewhere, at everywhere it also converge. Okay. How about the second one? Okay, similarly, we have to check the ratio. So this is just n plus 1 factorial times x to the x to the power n plus 1 over n factorial times x to the power n. What's this limit here? Want to measure this limit less than 1. And the limit here is n plus 1 times the absolute x less than 1. Okay? So when is it possible? Infinity and something less than 1. Not possible. Since not possible. Not possible. What kind of x you can pick? You can pick x. Can you pick some x such that this is true? 0. Okay. The only way is you make the coefficient 0. Okay, you multiply with 0. So this is true only when the absolute value of x is 0. Not that I say that the absolute value x is 0. Okay. So how about x? The length of x is 0. When is length of something is 0? It's only 0. Okay, only 0 have this property that the length is 0. Okay, so this is a very important property of your modulus absolute value. Okay, later on you will learn a generalized version of this absolute value, which we call norm, or maybe you met it before, norm. Okay, length. Okay, this is a very important property of this function here. Okay. So something is a 0 length only when it is the 0. Only when x equals 0, the series converge. When x equals 0, what happened to this series? It's just a 0 series. Right? It is just a 0 series. Okay. So in this case, it means that you put n factorial, you surely diverge. Okay, if it appears. Okay. So from here, okay, we got 3 cases here. Okay. You see, the first case we converge as an interval. Second case converge everywhere, and then third case converge at one point. Okay. So we have theorem here. We got a theorem. The set on which a power series converges is always one of these 3 types. Okay, so what are the 3 types here? So first type is just a single point. Okay, single. S equals 0. And then as an interval. Okay, as an interval, maybe from minus L to L. Okay. So possibly plus some endpoint, like what we do just now. Okay. We need to check whether the endpoint converge or not. Okay. One or both. Okay, so I need to check. Because at endpoint, the ratio test is inconclusive. Okay, it's inconclusive. And then the third one is the everything, the whole real line. Okay. Hey, did you notice anything? These 3 points, these 3 types have one similarity. What's the similarity? I think there's only one way to think about it. The first one only has 1 point. So to be the same as the first one, you also need to have that point. Okay. So you can see that the second case also like center around 0. Okay. Real line confirm contain 0. Okay. So there's something to do with this 0. Why? Because just now we define this power series at x equals 0. Okay. We are kind of like expand at s equals 0. So what do I mean by expand? Later when we touch about tail series, I will show you the picture. Okay. Okay, so in this case here, is definition. Okay, the number L. Okay, so L is called the radius. Okay, radius of convergence of the power series. So you see, why we call radius? Radius means what? Radius or circle means what? The line from the center to the circle. Okay, so this radius here from where to where? From the 0 to the end of your interval. Okay, okay. Can imagine. So we got the interval minus L and L. Okay, in the middle is 0. So here is your radius. Okay. So in this case here, we would say that the first case would have r equal to 0 in first case. Okay, so this, okay, so radius of convergence in 1 is r equals to 0. Second, r equals to L. Third one, everything. So radius is how big? Infinity. Radius is infinity. Okay, good. Then we will also call our interval when the power series converge as the interval of convergence. Okay, interval of convergence. Interval of convergence of a power series. Okay, is the interval consisting OX when the series converges. Okay. So what are the example of interval of convergence? So the first one is just a point. Okay, just a point. And then interval, what kind of interval? Open interval. Okay. Half open. Half open, sometimes we call it open. Close and open. Okay. And then close. Okay, maybe both endpoints also converge. And then the third one, we will say negative infinity to infinity. Okay. Not that we don't put square here. We never put square for infinity. Why? Because infinity is not in half. Okay. Infinity is not in half. So when we write like this, a bit ambiguous, but when we write like this, we doesn't mean the radius is really infinity. We just mean the third case, the whole real line. Okay, this is just what notation. Okay, this is not really r cannot take infinity. Okay? Yeah. So when we say r equal to infinity, actually we meant the power series converge at the whole real line. This is what the equal means. Okay. Itself, it doesn't mean anything. Okay. Yeah. So this theorem, right? This theorem here, if you interested, you can go and find the proof. Okay. Yeah. And then you can try to do it. Okay, so like what I said just now, we have a power series centered at 0. Okay, but more generally, we can consider power series center at A. Okay, so what do we mean by center at A? So how about I trigger you a bit before I talk about this? What do you mean I want to trigger you? So let me finish this example and then this definition, and then we'll take a break. So how to shift stuff? So for example, how to shift y equals to x? How do you shift this function here? How do you shift left, right? Yeah, left, right of the shift. Actually, in this case, you're shifting left and right, shifting up and down is the same. Okay. Yeah. So how to shift to left, right? What you do is you add a number to x. Okay. So you can shift here, for example, let's say this is 2. This is, so in this case, this is y equals to x minus 2. Minus, you go to the right, and then to the left. For example, this is minus 2, then this will become x plus 2. Okay. So why I say shift up and down is the same. You can see that when you shift to the left or right, you actually already shift up or down. Okay. So this property is what? It's covered by the intersection here. Okay. And then why take minus 2, you go to the right? Because in your mind, right, your right should be bigger, right? But now become less. Why? Because when you sub 2 into x, you should get the same value as you started. Okay. So you should get 0. So that you need to take away. So meaning your x increases, but your y shouldn't increase. Okay. So that's why it becomes minus 2. So you need to compensate with your x. Something is increasing, your x is increasing, but your y don't increase. You need to compensate your y. Okay, so in this case here, we also need to take x minus something. So where does the x minus something appear here? Okay, so it's exactly at the x position. Okay, so we have Cn times x minus a to the power n. Okay, instead of x to the power n. So you can see that we can recover the power series center at 0. How do we recover? How do we recover the power series center at 0? Just set a equal to 0. Okay, so this one is a more general case because it covers the case where a equal to 0. Okay. So in this case here, so we let's say we want to study this theory, right? Okay, we will also have the same theorem here, same set of theorem, but what? But we replace Sn by S minus An, okay, and then we replace the single point as the center point A, okay, and then we also need to shift, okay, we need to shift our interval to A, okay, we need to shift our interval to A, and then whole real line, no matter how you shift, is still the line. Okay. Okay. And then let me see. Okay, let me cover one more line and then we take a break and then later we'll come back to exercise. So one more line is not that if n into the infinity, what am I doing? If the limit of the coefficient, okay, over Cn is equal to L, then your radius of convergence is 1 over L. Okay? Can you understand this segment here? So here, the limit here, no more x inside, only has coefficient. But it tells you that if you compute the ratio of the coefficient, okay, 1 over L is the radius. You believe or not? You believe this? You believe this? Believe, so fast believe one. Don't believe people. Okay, why true? Why? Why is R? Radius? Ratio? So remember how we compute just now. Where's the compute? You see? Where's the Cn here? You see? Where's the Cn part? So Cn is this part. Cn plus 1. Cn is this part. Okay. And then what we do? Actually, we really compute what is Cn plus 1 over Cn. Okay. But you see, just now what we say, the limit only have effect on the Cn and Cn plus 1, not the x. Okay. And then this part, this limit here is what give you this 2 here. Okay or not? Okay. Okay. Okay or not? See? 2 is equals to 1 over 2. Okay. 1 over L. So this part is the L. Okay. Can get it? Okay. If you can get it, try and prove it. When I say prove it, don't use this number. Okay, use our argument here, ratio test. Okay, on general series. And yeah, so let's take a break until 2:06, and then we'll come back.
这个是需要这些需要这个因为这边这样。在你老不太好，如果这个声音要输入到这样好的原因是，你要找他们管专。好的。来怎么样？来一个在那个文学到不是面。是这是看，还是就是。这变成不准地，对。然后我们到时候你去用那个那个创作训啊，那个最后一个。也是没办法，这样子，也是我的隐私是不的。 我的名词上面的。有一酒，什么也吃不起。
这个 M 在变走了，我这个只有一个，在变走外面，里面有点变。但是是一个 fix 号码，这个不是一个 fix 号码，这个是每个 M 都在用。所以说出来的其实是多少钱？whole number 是说我选一个，啊，这个是对的，每一个选哪一个都对，这个才是叫做 whole。但是一下子出现全部都是这样，它这个一次的能力是那个。对，这边有很多个，里面那个每一个 n 作为龙圈，那个里面 n 个里面不一样，就对你的话不一样的。Are we ready to start? Ready to start? Okay. Okay. Please go home and then try these two series. So for these two series, find the interval of convergence and radius of convergence. Okay. So be careful. These two words you need to learn whether I asking for interval or radius. Okay, both you need to know how to find. Okay or not? Radius and interval. Radius of convergence, interval of convergence. Because some students they thought interval is radius is interval, then they write the wrong answer. Okay. Radius is just one number. Okay, interval is a set. Okay, interval is a set. So how to find? You need to use ratio test. Okay, ratio test on an plus 1 over an, and then make sure the limit is less than 1, and then find what happened to the x. And then if your interval is a finite interval, what you need to do? You need to check the endpoint. Okay, you need to check endpoint. Why? Because ratio test is inconclusive at limit equals to 1. Okay, so inconclusive means what? It may converge or diverge. Okay, so you need to check. Okay, you need to sub the value into it and then check the series. Okay, how to check the series? Use all the tests you learn. Okay, what kind of tests you have learned? Test for divergence. Okay, and then P series, geometric series. What else? Integral tests, and then comparison test, direct comparison test, limit comparison test, and then, right? Yeah, limit comparison test, and then alternating series test. Anything else? Ratio test, root test, 9 already. Anything else? Absolute convergence test. Good. Okay, absolute convergence test. So if the sum of the absolute an converges, then sum of an converges. I think 10. I think it should be 10. Okay. 10 skill you learn already. Make sure you use them. Okay. So let's go back to the business of the infinite thing equal to finite thing. Okay. So this is what we call the representation as power series. Okay. Yeah, so just now we observe a phenomenon. Okay. We can express 1 over 1 minus x as 1 plus x squared plus x cubed and so on. Okay, so this is what we observed just now. Still remember? When is this true? Just an hour ago. When is this true? Absolute value of x has to be less than 1. Okay, less than 1. Okay, so on the right, on the left, on the right, your left or your right, my right. Okay, on the right hand side, 1 over 1 minus x is a closed form of the left hand side. Okay, my left hand side. 1 plus x squared plus x cubed are like what I said just now. Form a linear independent set in the polynomial function. Okay. So this is a basic equation. Okay, basic equation. So if you add up 1x, 1 plus x, power of x, then that equals to 1 over 1 minus x. Only when x is less than 1. Okay, only when x is less. So how is this useful? How is this useful? So let's say, for example, so you see this topic here, we want to represent our function as a power series. Okay, as power series. So let's see. Can we express how to express 1 over 1 plus x squared? Okay, as the sum of power series. Of a power series. Any idea? And then find integral. Any idea how to do it? The only information I gave you is this one. What's the similarity here? Both of them is 1 over 1 plus something. Okay. So can I write 1 over 1 plus x squared in this kind of formula? How? So you need to write as 1 minus something, which is minus x squared. Okay. So it's like we change variable here. Okay. Can you see that these two are similar here? 1 over 1 minus something. The something here is different now. Okay. So let's say we change this variable to minus x squared. Okay, so what happened to our power series? We also sub all the s as minus x squared. Okay. So in this case here, what happened? If I expand this out, we'll get alternating minus 1 of x times x to the 2. Okay. So similarly, the condition becomes absolute of minus x squared is less than 1. So how does this affect my x now? This implies what? Absolute of x squared is less than 1. Okay. So where should this x lies? X squared is always positive, so I can get rid of my absolute number. So when does x squared less than 1? Yes, s is in between -1 and 1, or in other words, the absolute value of x is less than 1. Does everyone know these two are equivalent or not? No. So let me give you this picture here. You must remember. So we got a -1 to 1. Here is 0 maybe. So your s is somewhere around here. Okay, can be anywhere around here. But again, the radius here, this is the radius from 0. Okay, because it's a length. It's less than 1. Okay. Yeah. No. Okay, so we don't care whether go to left or go to right. Okay, so as long as it is one distance from 0, that's enough. Okay. Any question? If you got question, please ask them. So in this case here, what's our interval of convergence? Interval of convergence is what? Is S at what's the radius of convergence? C. Right? Where's the radius of convergence? From where to where? Here, answer here. Here. From where to where? -1 to 1. Okay, -1 to 1. Okay, not including endpoint, because we don't start with endpoint. And in this case here, what's the radius? Okay, seeing you 0.1%. Give you the privilege today. Who? Wait. Let me test my name first. Ro, not Ro something. Sorry. What's your name again? What's your name? Tom. Okay. Yeah. What's the radius of convergence in this case? Zero? Zero? This radius, what's the radius of the interval? What's the radius of the interval? Radius of interval. 1. Okay. So the radius of interval is 1. So get R equals 1. Okay. Okay or not? Hello. Hello. So radius of convergence depend on your interval of convergence. Okay. Your interval is from -1 to 1. Okay. So your radius is 1. So this one here also similar to this x here. Absolute value of x is less than 1. Okay. 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 Let's try one more. Okay. Let's try one more. How about let you try two? Let you try two. Okay. At one go. So try and do two. Check for these two. 1 over x plus 2 and x cubed over x plus 2. Can I give you? I think 3 minutes is enough. It's very quick computation. Try see if you can relate. Can you relate these two? Okay, can you relate these two to 1 over 1 minus x or no? Can I give you 3 minutes? Okay, see some of you done already. Yeah. This one, like this. Can you see? You want me to zoom in? Okay. Okay. So let's discuss. Don't tell me your answer yet. I want you to check whether you do the same as mine. If you are different, and then you let us know. Okay. You let us know if you are different. Okay. So for the first one, okay, what can I do? I can divide 2. Okay, I can divide 2 on the denominator. But doing that, I'm pulling out the constant half, right? Okay. And then how to relate to 1 over 1 minus x? We just introduce another minus sign. Okay. And then from here, we do the same expansion. So we substitute x to be minus x over 2 to the power n. So this is only true for n. The variable is less than 1. Sorry, so minus x over 2 is less than 1. This implies what? This implies absolute value of f has to be less than 2. Okay. And so altogether, we can write it in this form. So minus x to the power n over 2 to the n plus 1. Okay. So in this case here, our interval of convergence is from minus 2 to 2. Okay. So our x is from minus 2 to 2. Okay. Not including endpoint because our equation started without the endpoints. Okay. So maybe I test Xiaotong again. So what's the radius of convergence in this case here? Don't tell her the answer. What's the radius of convergence? 2. Okay, so the radius of convergence is 2. Good. Okay, how about x cubed over x plus 2? Okay, so there's no longer 1 anymore, okay, on the numerator. So what we do? We just pull the s cubed outside. Okay, but not that. We already know 1 over x plus 2 from part 2. Okay, so we just take s cubed, multiply what we got before. Okay, so meaning you should also inherit the radius of convergence here. Okay, you should also inherit the radius of convergence. You see, not that, where did I put this condition? Whenever I go to the series. Okay, whenever I go to the series, I put the condition here. Because remember, we are adding infinitely many stuff, you know. But you know that that series might diverge. Remember, we use ratio test. When does it converge? Only when the limit is less than 1. Okay, if it's greater than 1, it diverges. So you need to put your condition at the side. Okay, whenever you write some closed form of function as some series, okay, make sure you write down the condition. So altogether here, we can combine on x in this case, which we get minus 1 to the power n over 2 to the n plus 1 times x to the n plus 3. Okay, and then we have the same interval of convergence and radius of convergence from part 2, part 1, part A. Okay, same interval of convergence and radius of convergence from part A. Okay, Any question about these two? Do you have the same similar solution or not? If you have different, just let me know. Just let us know, and then we will see anything's wrong or not. Okay. Please, I want you to believe in yourself. Okay. What do you mean by don't believe on yourself? Eh? Like when you ask me question, right? You are saying, 老师可以帮我看一下这个对吗 ？Teacher, can you help me see whether this is correct or not? Not just you, everyone. Okay. What does it mean? What do you mean like? 为什么你会这样问？你知道吗 ？Have you think about it? Why you ask like this? First, you're not sure what you are doing. Okay. Second, you don't believe in yourself. Okay. If you are sure on what you're doing, every step you do should be line by line. Line by line means what? I know this and then I do this. I know this and then I do this. It's okay if it is wrong. Okay. If it is wrong, it's okay. Correct it. Okay. Wrong, correct it. Okay. It's okay. Not a single person will do right every time. Okay. So it's okay to make mistake, but you need to correct it. Okay. Okay. So next time, don't ask me whether this is correct or not. Ask me some question that we can try and figure out is true or false. Okay. You get what I mean? You get what I mean? Okay. So it's like the step question you need to ask me. Okay. Don't ask as a whole. How should I check? Right. You get what I mean? You get what I say? Yeah. Okay. So try and believe in yourself. I know because so we raised out in the Asian culture, right? Okay, where sometimes you get score, you don't even know why you get score. So you just follow what people do is enough. As long as other people are happy. So yeah. But this is not the case when you want to go and do a research or what. When you want to try and lead on yourself, it's different already. Okay. You have to know what is right, what is wrong. If it is wrong, then correct it. Yeah. Then correct it. But sadly, this is not the case in this world, especially those in power. Although they did wrong, they don't care because they got power. They are in power. Right. So remember, next time when you are in power, please admit your mistake and then do it right. That's all. It's easy. Okay. It's easy. Okay. Okay. Let's continue. Okay, so let's come with this motivation on the geometry now. Okay, so let's do this analysis for calculus. Okay, in your case, it's calculus with geometry. Okay, so again, and again, you have seen this the third time already. 1 over 1 minus x is 1 plus x squared plus s cubed plus s4 and so on. Okay, so now I want to refresh your view on this series again. Okay, how to think differently about this thing. So think of it as a function. Okay, function. What's the function 1? Yeah, what's the function 1? Y equals to 1. Is a y equals to 1. What's that function? Everything sends to 1. Yes, it's the function constant function 1. Okay. Y equals to x. Fx equal to x is a linear line. Okay, it's still a linear line. X squared is a quadratic line. S cubed, something like this. And then S4, a bit fatter like this. Okay, and then so on. Okay, so you see, we are adding values on this function. We are adding values on this function. So
In particular, if I take all the values here and then I add up, what happened? You should think that these values will add up together. Okay, so the shape will change. So how does the shape change? Does anyone know how to plot the right hand side? Yeah, my left hand side. 1/1 minus x. You know how to plot it? So the basic graph is 1/x. 1/x how to plot? And the other one go down. Okay. So shifted by 1 minus x. So how? Minus x meaning you need to go here first. Okay. So +1 or +1 go which side? The left. The left. To the right or to the left? Okay. Let's check. So when s equals 0 is when s equals 0, 1/1 minus x is 1. Okay, so you will intercept 1. So you go. Okay, you go to y intersection at 1. Okay, yeah. So what's this bunch of thing doing here? What's this bunch of thing doing here? Okay, what's this bunch of thing doing here? So we said that this is an expansion at 0. Okay, so we look at x equals 0. Okay, let's zoom in a bit. So s equals 0. Zoom in. Okay, s equals 0. In this case here is here. Okay, we zoom in here. First term is 1. Okay, 1 is equal to the y-intercept here. Okay, so the first term equals to the y-intercept here. Okay, so this is the y equals to 1. Okay, so your function is y equals to 1/1 minus x. Okay, the second term is x squared. Okay, and then if I add, the second term is x. So 1 plus x is what? X is like this. 1 plus x is something like this. Okay, so can you see that the first term here you see it agree at a point. Okay, when it is y equals to 1 plus x, it agree a little bit more. Can you see it? Here is y equals to x, and then you shift out 1. Okay, they agree a little bit more. Okay, and then if you add s squared, what happened? The curve will curve out. Okay, so the curve will curve out. So maybe something like this. Okay, something like this maybe. Okay, and then it will agree a little bit more than the previous one. Okay, and so on. You will add s cubed, and then s4, and then s5, and then x6 like this. You agree more and more and more. Okay, so when they agree, like when they are fully agree, they fully agree in between -1 and 1. Okay, so if you add up infinitely many, then the function on the right hand side will agree from 1 to 1, something like that. Okay, so this is what we are doing. Okay, remember the first class, the first motivation I gave you? We want to zoom in into a curve. Okay, we zoom in into a curve. When you zoom in into a curve, you just see a straight line. Okay, but when you zoom out again, actually it is curved. Okay, this is similar to you. Is this flat? Looks flat. Okay, if it's not flat, you already like go down by the gravity. So looks flat, but if you go to the outer space, you look back to the Mother Earth, what do you see? It's spherical. Okay, so it's locally flat. Okay, so here is the same. locally flat. Okay? You can't discern the difference. But when you go outside and see everything, you see it from a global view. Okay, you are like a bird, see from a global view. Okay, so this is why we devise these power series here. Okay, because we want to check the property of our function. Okay, we want to find the value of our function. Okay, so we will let's see what's the next. Okay, so next theorem. So this is a function, right? So function, what can you do with function? You learn calculus. What do you do after you get the function? Huh? Yeah, differentiation and integration. This is exactly the Chinese name of calculus. 微积分, 微分 and 积分. Okay, 微分 is what? Why is it 微? Wei is what? Yeah, why is small? Why is it small? Why differentiating is small? That's not what we do. We go see the local point, very small. Okay, this is differentiation, small change. Look at this local property. Okay, and then 积分 is another thing. 积分 is the sum. Okay, so now we will do a differentiation and integration on power series. Okay, so how do we do? We'll do it term by term. Okay, every term we will do differentiation and integration in our power series. So what's the condition? So the condition is, let's start with a power series. Okay, and then has a radius of convergence greater than 1. Okay, so greater than 1. Have a convergence greater than 1. So meaning if it converges at a single point, we don't really know about it. So if it is greater than 1, then we can do differentiation or integration. Defined by f prime equals to the power series. Okay. So you need to be aware here. I need to be aware here. You have infinite terms how to do differentiation. Okay. So somehow you need to control the infinite terms. Okay. You need to have a formula of it. So it's differentiable. Okay. Differentiable at where? At the interval. Only on the interval. On the interval a minus r, a plus r. Okay, so meaning if you have a power series, okay, and then it converges at the radius of convergence or the interval of convergence, then it is differentiable. Okay, then the power series is differentiable. Right. So for example, this side here, okay, 1 over 1 minus x. Is it differentiable or not? Can you find the derivative? 1 over 1 minus x. Derivative of 1 minus 1 over 1 minus x. You can use the product rule, quotient rule, anything you like, okay, to find. Around x, it is differentiable, okay? It is not differentiable at this vertical asymptote, okay? But around here is differentiable. So if this is differentiable around 0, then the power series also differentiable. So how to differentiate a power series? Okay, so how to differentiate power series? We exactly differentiating terms by terms. Okay, we're differentiating term by terms by term. So the first thing we got is differentiating term by term, which we get as n times cn times s minus a to the power n minus 1. Okay, not that there's nothing to do with cn. Cn doesn't have x. Okay, Cn is a changing number. Okay, it's a changing constant. Okay, so you don't need to differentiate it. What you need to differentiate, you need to differentiate the x minus a. Okay, and then we can integrate it. Okay, we can integrate it. We can integrate our power series. Okay, how to integrate power series? Okay, similarly, you add the power on your x term, and keep your constant, and then divide by n plus 1. Okay, term by term, term by term. You want me to write down what do you get? So for example, for derivative, you get C1 plus 2C2 minus x minus a plus 3C3 x minus a cubed squared. And then on integration, you get C0 times x minus a plus half times C1 times x minus a. 2 and so on. So how does this compare to the original series? So your original series start with a constant. Okay, and then C1 times x, the first degree, and then C2 times the second degree, and so on. So you can see that differentiation, your constant gone. Okay, your constant gone. And then when you integrate, your constant get level up to x. Okay, so this is matching the differentiation and integration. So in this case here, you should ask, what's the radius of convergence? Why? Because on the left-hand side is a closed form. Okay, on the right-hand side is some series. Okay, remember this example here. You can integrate 1 over 1 minus x. You can differentiate 1 over 1 minus x. Okay, you got a closed form. But on the right-hand side, still infinite. So how? So the radius of convergence is still the same. Okay, still inherit from the radius of conversion of the original power series. Okay, so in 1 and 2 are still up. Okay, so inherited. So you are safe. Okay, so within the radius of conversion, just differentiate every term, just integrate every term. Okay. I think in one of your assignment got this kind of question. That's why you need to take note. Is it? I think so. Okay. Okay, let's continue. Let's try this theorem. So Seng, we don't prove this theorem, so you can have a look if you like for the textbook. So let's do example. So determine the radius of convergence 1 plus 2x plus 3x squared plus 4x cubed. Okay, and then find an explicit formula of the series when it converge. Meaning find the closed form of this function. So what's the first thing you will do if I want to find radius of convergence? What's the first thing you do? Yeah, radius of convergence. What's the first thing you do? Use what? Ratio test. Okay, you use ratio test. You use ratio test an plus 1 over an less than 1, and then you find what's your x. Okay, x has to satisfy. So first thing you will try this. Okay, but you can try it yourself. In this case here, we will use more advanced tool. Okay, which is the theorem just now. Okay, and then relate back to what we know. Okay, what do we know? What have we done? Okay, what have we done? So, not that this series here, okay, you can see a bit awkward here, It's like you attach 1 here, but you attach 2 to x. The power of x is 1. And then 3, you attach 3 to degree 2, attach 4 to degree 3. Seems like they are like off by 1. So what's the operation that can make you off by 1? Off by 1. Off by 1. Sorry? Yeah, try. I guess. Huh? -1. What did you say? Differentiation? No. Not here. What did you say? Integration. Integrate what? Everything? You want to integrate everything? Want to integrate everything. So let's try. I'm not sure. I haven't tried yet before. So let's try. So what do you get? So you get x plus x squared plus x cubed plus x squared. I think also work. Yeah, I think also work. Okay, I think also work. Yeah, I think also work. Okay, you can do this. Okay, or you can also differentiate. Okay, differentiate what? Differentiate the same guy. So what? So this is yeah, okay. So let's see what I'm going to do first, and then see what we can continue here. So both of these are not quite we know, not quite the thing we know yet. What do I mean by that? Because what we know is 1 plus x squared plus x cubed plus x4 and so on. Okay, so how to introduce the 1 back? In my case, it's easy because you differentiate 1, you get 0. Okay, so you are like adding a 0. So I can just add 1 into my function. Okay, because differentiating 1 is 0. Okay, and when is it true? Okay, so when can we do all these weird stuff? This is only true when it is 1 over, when the sum is equal to a closed sum, which is 1 over 1 minus x, which is when x, the absolute value of x is less than 1. Only when this is true, then you can do all these weird stuff. You can differentiate 1 by 1, 1 by 1, 1 by 1. Okay. Okay. So what? So this is, so we can differentiate 1 over 1 minus x around 0. Okay? Not away from the vertical asymptote, we can differentiate. In this case, we'll get minus 1 over 1 minus x bracket square. Okay. So what's the radius of convergence? So the radius of convergence, so what do we get here? So we get that the 1 plus 2x plus x squared plus 4x cubed is actually equal some closed form, which is minus 1 over 1 minus x squared. Okay, so you see here is an infinite thing. Here is a closed form. So what's the radius of convergence? So the radius of convergence has to follow what function you differentiate. Okay, so in this case here, the radius of convergence should be Sydney. Where's Sydney? What do you think is the radius of convergence? Huh? 1. Because we have this 1 condition. So if you do this, so if you do this, so what are you going to achieve here? Yeah, any idea? Or you mean there's minus outside? Okay, wait. Outside? Wait, outside where? Outside here or outside here? This one, the last line. You mean should be a positive here? Oh, okay, yeah. Okay, good. Okay, yeah. So I have a minus, so it's okay. Okay. Yeah. Yeah. So one of them coming from the power and then one of them coming from the coefficient of x. Okay, chain rule, yeah. Yes, chain rule. Okay, so if you integrate like this, right, is the inside yet. Maybe I know about outside. So outside is true when it is equal to 1 minus. Okay, I add a 1, so I have to add 1 and minus 1 to it. And then and so on. And then this is 1, so it's a minus 1 plus 1 over 1 minus x. So this is true when x is in between 1 and minus 1. So what you get is integration of the whole thing here is this thing. So I think you need to differentiate also. Okay, yeah. Because we're out of time, maybe next time we'll try example on integration and then we'll finish up the series. Okay, and any question before we break? No? Do you have enough tool to do the assignment yet? I forgot what I put inside the question already. Do we have anything we haven't covered yet to do the assignment? Maclaurin series, I put a question on Maclaurin series. Okay, let me see. No, I don't think so. This don't need no Taylor series and Maclaurin series. This is not. So I think you have enough tool to do already. Everything, yeah. Yeah. So there's a number 6, right? Number 6, number 6, part 1, part 2, part 3, part 4, they follows one. So you need to use the previous result. Okay. So if you start on one, even if you start on one part, you still need to able to use the previous result to do the next question. Okay. So there's a reason why they're in the same subtopic. Okay. So don't use outer source to do the question. Okay. All right. If you have any questions, just feel free to email me or see me in my Facebook. Okay. Okay. See you next week.
用讲过的，对，用讲过的那一题要用前面的那些就要用前面的。我知道要用前面的。